doesn't it? I'm up and running. Can everyone hear me?
Yep.
Hello, my name's Hannah. I'm here to talk about the messy reality of container security in the real world, because something as simple as fixing a vulnerability in a container image can get very heckin' complicated in big enterprises where you have shared ownership of different domains. First, let me introduce myself. So, I started working in cloud native when I was in a company called Pivotal. Our purpose was to transform how the world builds software, and we helped get people, our customers, started on Kubernetes. We held their hands through that first initial journey of spinning up their first cluster and containerizing their applications. We continued to do that after we were acquired by VMware, so I was Director of Platform Services at VMware Tanzu, and more recently I was Director of Sneak's container security product, so Sneak Container. So I've been thinking about containers in the real world for quite some time now, and I'm going to share what I've observed and what I've learned in this talk. It's not a deeply technical talk. It's a talk about people, process, and organizations, and how this can make the challenge of security so much harder when it meets the real world. But first, I'll tell you the story of my first zero day. How many folks in here have had the pleasure of working through or leading a zero-day vulnerability response? Okay, so we've got some empathy in the room, some empathy. So this is the story of October 2022, when OpenSSL notified the world that they had discovered a critical vulnerability. And of course, everyone's reaction was, oh no, it's another heartbleed. It's another heartbleed. Oh no, oh no. And so it was very immediate, our response. We'd seen it and done it before. We knew it could potentially be bad. OpenSSL is packaged with a lot, if not the majority, of Linux distributions. So there was a good possibility that this vulnerability was present in all of our container images. We needed to go and check. So we did, and it was. The vulnerability, or the vulnerable package, because the vulnerability hadn't yet been disclosed, was present in all of our container images. The container images were built from Docker files, and every development team across our organization had their own Docker file and managed that process themselves. We had a product security team who were in the process of procuring secured sort of premium base image catalogs, which had SLAs associated with them. They had not procured those images yet. And so we were very much like working through what our response should look like. And this is the message I sent to the whole organization, because I was leading that response. I said, when the vulnerability is disclosed tomorrow, we can't do anything. We have to wait until all of the different operating systems that were affected have patched the vulnerability, and they have published new versions with the fix in it. We then have to wait for the people who build the image catalogs that we run to update the base images that we build our containers from. We then have to wait for the container registries who publish those images and where we pull those images down from to validate those images, make sure they're good and conform to their standards, and then publish them, so that we may then pull those images into our internal container registry. We then need every single development team to go and find their Docker files where the impacted images are present and update that from line, one line change, but we needed every single development team in our organization to engage in that process. It was a highly coordinated effort, and it involved probably up to 100 people. And that is how we prepared for that potential zero day. Of course, it didn't end up being a zero day. If you managed that vulnerability or you were aware of it at the time, by the time it was actually published and disclosed, it was recategorized. It was 2 vulnerabilities and not 1, and they were downgraded to highs instead of critical. And so sort of breathed a sigh of relief at that point, but also, nevertheless, we had to go through that process. We had to go through that process with all of those people involved. And I always talk about this because of the disruption it potentially caused, because of the coordination overhead. And this was a relatively small company. This was a company with an R&D organization of about 300. I've been working with enterprise customers for a decade, and that is small by comparison. A lot of the customers I work with have more than 10,000 developers. Some of them even have like tens of thousands. Like I think the one I spoke to most recently had 40,000 developers. And you cannot put a human on that task to coordinate that response across that many people. And so a one-line change in a single file may sound like a small response, but actually when it meets people and process and practice in the real world, it can get a hell of a lot more complicated. And so this was the situation where I worked. We had multiple dev teams, more than 4. We had a platform team, we had ProdSec, and then we had people outside of our organization who were on that chain of response and who we were waiting on that morning to fix the vulnerability. We had open source maintainers, operating system providers, we had our base image providers, and we had our container registries that we were dependent on. And when you multiply that by 100, like, what does it look like? You know, dev team, dev team, dev team, dev team, dev team. Do you know where all your Docker files are? Are you in a homogeneous technical environment where you have one source code management system? Probably not if you're a big enterprise like a bank or a government or a retailer. Do you have a single platform team that curates your base images? Maybe you do, or maybe you don't. Is your security team aware of these processes and practices? Are they aware that as well as responding at an operating system level, patching their VMs, that they now need to think about going and finding every single Docker file in their organization? Not every security team has that awareness of how containers are built. Of course, there's like layers and layers within the security organizations themselves. There's the SOC in a lot of organizations, the Security Operations Center, people who manage incident response. There's change approval boards. If you want to get a change into production quickly in a bank, good luck. This is probably one of the only scenarios where it actually makes sense to circumvent the processes and actually push changes quickly into production. And then, of course, this is probably a simplified view of what it looks like in the real world outside of your organization. And if you're running multiple versions of operating systems and you're behind on your patching, this is going to be even harder for you. And so I've had a lot of conversations with my customers in the enterprise space, in the big company space, and I always start with this question. It's just like, who's managing your base images? Who's choosing them? And people and teams, they exist somewhere on this sort of, somewhere on this spectrum of complete developer autonomy. When the dev team decided to build a new app, decided to build a container, they selected a base image from somewhere. You don't know where, but they selected it. And that's what they use. And it works, and so that decision was never revisited ever again. At the other end of the spectrum, you get the highly centralized and highly controlled organizations where every single itty bitty bit of software needs to go through a very strict approval process to enter the organization. And so these developers, they have to select from a very small catalog of approved golden images. And it can take weeks or months to get a new image into that catalog because of the hardening it needs to go through and the assurance processes and the approvals it needs to go for. This is the reality. This happens at a lot of the banks I've worked with in the past. And then there's organizations that have a scattered approach. They have maybe some very highly mature cloud native dev teams. They're like, have at it. You're over there. Be free. But they have some teams that have been established for a long time. Maybe they've just migrated some of their legacy applications into containers, and maybe they're not ready to be trusted with this decision making. It's not a one-size-fits-all view. A lot of companies actually have teams that operate on different levels of maturity and different levels of control and visibility. There are trade-offs to be made here. Over here with developer autonomy, you have less visibility as a security team about what software is entering your organization, but you maximize developer productivity and freedom. They can just get shit done. Over here, you've got a lot of visibility, but the trade-off is, of course, speed can you get the tools that developers need into their hands quickly? Are they unobstructed in what they need to do to deliver value for the business? And this is the issue we have with containers, is that they smoosh together a lot of different domains of expertise. And it's great because you ship your apps with everything they need to run, and we've completely resolved some of that challenge of like, it works on my environment, don't know why it doesn't work over here, and that's a great thing, and that's why we love it. But what we've done is we've smooshed together a lot of the legacy organizations that might have existed in the past. So if you were running on a VM, chances are your infrastructure team just took care of operating system versioning and patching for you. You didn't have to worry about, you didn't have to think about it. You just packaged your app. You only cared about your app. And so, actually, I forgot to talk about this slide. And so, yeah, the complexity has layers in it. The complexity has layers in it because, of course, you select your base image, but your base image might be built off another base image, and that might be built off another base image, which might be built off something that's highly customized and includes your operating system dependencies. You might select a very thin base image layer, or you might select one that comes with everything. It depends on your environment. But there are lots of decisions to be made when you select your base image. But what I was talking about before is that smooshing of domains and expertise, because the bit developers care about is really only their bit of code. And that's absolutely the right thing to do. I think the caricature of like the developers that just don't care about production, I think it's old and outdated. I think dev teams care about delivering because delivering updates to their software drives business value. There's a reason that they have their backlog. There's a reason that they're doing the work that they do. Developers only care about their code because that's the code that the business care about. Everything else is necessary complexity to help it run, but it doesn't deliver value immediately. And so we talk about the rest of the complexity. And so when we delegate all of that complexity to our development teams, we're asking them to do a lot more work. And you've probably heard the term cognitive load in the context of developer experience, building internal platforms, and also in the context of team topologies and org design. And it's very real. If you delegate all of these different technical domains to your development team, you're asking them to divert their attention from the thing that they were hired to do to deliver business value to something else that actually traditionally was done by a different team and provided for them. And that's the challenge of cloud native. It's this smooshing of domains of expertise into often a single file, the Docker file. So the thought experiment I always ask my customers to go through is, what if every day was a 0 day? So we went through that 0 day response and that planning to the OpenSSL vulnerability, and that was my first time on the front line. And I was like, oh my gosh, we need to do better than this. And so this is what I ask people, is like, what if every day was a 0 day? Would you put somebody full-time on that? Would you have a coordinator? Would you do these spreadsheets? Would you do this checking? Would you allow your dev team to be interrupted in this way on a daily basis? Because it's not just critical CVEs, it's not just about 0 days, it's about the constant emergence of new CVEs. And in your context, a critical CVE might not matter. You might not be using that package, your code might not be following that code path, but a high CVE might be highly utilized in a business critical application and might be more important to you. It doesn't really matter. It doesn't really matter if it's a 0 day or not a 0 day. You need to have an automated process for managing CVEs. Because, and I'm using this, this is the total number of CVEs, because actually, especially when I was at Sneak, when you first go into a customer environment, it's not just the shiny new CVEs that you find, it's a lot of the old ones too. They've been hanging around, they forgot about those CVEs. And so it's too much information for a human to manage. CVEs for a security team are absolute nightmare because they create noise. The interpretation of severity is very important and contextual. Which application is impacted by this CVE? Does it have, is it running in a cluster that's got access to the internet? Is it in a code path that's actually highly utilized? Are there exploits for this CVE available online? Is this highly shared and highly exploitable? The interpretation of severity can even come down to a bit of a fight between vendors. Not every container scanning tool will give you the same criticality for a CVE. And actually, this is something that we had a lot of frustration around when I was at Sneak, because there are a lot of CVEs, criticals and highs, shipped with Ubuntu. And Canonical will always say, it's not a package we use, it's just part of the distribution, nothing we're going to do about it, we've ignored this CVE, you should too. Well, it's there though, isn't it? It's there. And so we scanned it and we told the customers it's there, and now everyone's panicking, and you're saying that it's going to stay, and it's going to be vulnerable in this sense forever, because actually it's not vulnerable at all by your definition. That's great, isn't it? That's really easy to navigate in an organization of 40,000 developers and a very tiny outnumbered security team. Yes, it's a vulnerability, but no, it doesn't matter in this context, and yes, we're reporting on it, and no, we're not going to fix it. Yeah, it's murky, and it shouldn't ought to be. False positives are a problem. Like CVEs can be reported when they're not actually present in the package. There are assumptions made by some container scanning solutions that will only take the sort of top level of the package, and they'll infer what the software composition of that package is, even if that package has been upgraded or it's not present. More is not necessarily better when you're assessing your container scanning solutions. Specificity is better. If you find more CVEs, that doesn't necessarily mean that the tool is better at finding CVEs. It might mean that they're inferring software composition at a higher level and they've not actually decomposed those packages into their component parts. Interruptions, as we've talked about, every single vulnerability, whether it be a 0-day or not, can create friction for your dev team. It can cause them to put down the thing that they were doing and respond to it. And then it gets murky when it comes to ownership. Who owns the CVE response in your organization? Is it the dev team? Is it the security team? Is it the platform team? Is it the people running the cluster? Who owns that? It's for sure a murky area, and it's an area where collaboration is incredibly important. It's not a job for a human being. This is what I've learned. Over 10 years of trying to do this, this is not a job for a human being. This is an area where we have to automate ourselves out of this mess. And if you're putting human beings on triage of every single CVE, that's a waste of time. Just fix them, just patch, make it easy to patch, make it low friction to patch. And so I'm going to talk about a couple of the patterns for success I've seen in the real world. And again, this isn't necessarily technical solutions. This is about people, process, and mindset, about actually how you tackle the complexity and the sprawl of these problems. But first, I'm going to talk about a bit of terminology for people in the room who aren't familiar with it. Can I get a little wave if you've read the book Team Topologies? Okay. So there's a lot of you in here who haven't read it, and so this is valuable for you folks in the room. So Team Topologies is a fantastic book. I recommend it. But what it gives us a new terminology around talking about the purpose of our teams. And they introduce the idea of a stream-aligned team. And this is generally folks who work in your development organization. They're aligned to a flow of work that's usually a segment of a business domain. They're usually building customer-facing features, these stream-aligned teams. And you want to make these teams as successful as possible, because that aligns very closely with the success of your business. And all other teams really are in service of the success of these stream-aligned teams. These are business-focused teams. And two types of teams that you want to talk about when you talk about everyone else being in service of the stream-aligned teams are enabling teams who help stream-aligned teams overcome obstacles, So they are your sort of education, your centers of excellence, your innovation teams. They are the folks who are doing the work that the streamlined teams don't have time for, or they're coming in and they're holding your hand when you're doing something new. That's how you think about the enabling teams. And then there's the platform teams, and it's easy to talk about a platform team in this context at Civo Navigate. We've had a lot of excellent talks on internal development platforms, developer experience, removing toil from development teams so that they could get shit done faster and better. And so platform teams, they're a group of other teams that provide an compelling internal product to accelerate delivery. This might be back-end services that take some of the business logic and complexity away from the streamlined teams, or it might be something like a Kubernetes cluster. You don't want your development teams building their own clusters. So I recommend, if you're in security or if you work with people who work in security, a new way of thinking about it. Start to view security as an enabling team. Not every developer can be a deep expert in security. They're going to need education and enablement, and they're also going to need some people they can go to for advice that are easily and accessible and available to help them make the right decisions. They need a platform team that remove interruptions. I talked about automation. This is the type of work platform teams are great at. Can we automate the process of bringing new base images into the organization and automatically updating Docker files and pushing those to production? That sounds really simple, doesn't it? Like, we're changing our applications all the time. We're always building new images and we're always pushing those images to production if we're doing it well. So adding base images, adding CVE patching to that process is an easy, logical step for a platform team. Can we rethink security as an enabling team to help facilitate incident response? So if anyone has read the Google book SRE, and when you talk about site reliability engineering, they see it slightly alongside development teams. But what they do is they focus on reliability, they focus on incident response. And I'm like, well, why can't security take that mindset as well, actually? Why can't we have subject matter experts in security who are running fire drills, not for outages, but for 0 days? How many times have you run a fire drill or a rehearsal for a 0-day vulnerability? How many scenarios do you have documented? Do you know how quickly you could respond? A lot of organizations I talk to can't answer those questions. And can we view security as a platform team to provide the technical building blocks so that we can build on top of them? Can the security team behave like a platform team in terms of providing a validated or hardened image catalog, a golden image catalog, so that you can build your containers so that you don't have to think about the base image that you build your containers from. Someone else has taken that cognitive load out of the team, and you just go, well, what's the right image for the app I'm building? Click, here it is. And so that's a very powerful way to improve security, and it's very simple. But you need that mindset. You need that mindset that as a security professional, I'm providing a service to my development teams. I'm here to make your job easier. This is how I'm going to do it. You also need to avoid the temptation of doing everything yourselves. You're going to introduce a lot of extra load and work into your organization, especially when it comes to 0-day and CVE response if you've done everything by hand yourself. That is then on you to update the versions of everything wherever you built it from. You can give that toilsome work to a vendor for a very small price tag, and I would recommend you do so because that price is always going to be less than the human cost of staffing up to be able to DIY this, especially with the volume and complexity and frequency that new CVEs are being discovered. Make very intentional decisions about whether you build or buy. And in this space, if you haven't checked out ChainGuard yet, their base image catalog promises 0 to very, very, very low CVEs. They've gone, what if instead of building a tool that finds CVEs and then goes, ta-da, what if we just got rid of them? Like, what if we just fixed them? And so I'm a big fan of ChainGuard. If you haven't checked them out, you should. They have free versions of all of their images if you want to experiment and get started. So I've kind of explained a lot of the reasons that when container security meets the real world, it can go horribly wrong. So I wanted to give you like one pattern for success that I've seen in a bank. I'll say that again, in a bank. This is a pattern for success I've seen. So the security engineering team maintain a catalog of golden images. They run tools that scan their Docker files in their source control. They also run tools that can identify the base images that are running in all of their production clusters. These clusters are on-prem and in pretty much every single cloud. This is not a simple environment. What they then do, if they detect a deviation from the golden image catalog, actually there's a better and newer version, they just automatically open a pull request on that Docker file. They can trace that container from production into the source control to that Docker file, and you're meeting your developers where they are. Developers are accustomed to receiving pull requests. And so all they have to do is accept that change. The next time the container is built, it has the new and updated Docker file, and that is automatically pushed to production with your next release. That sounds a lot better than trying to track down every single dev team to make sure that they're not running a vulnerable base image as part of their pipeline. And so I'm going to wrap up here. If you're sat here thinking, oh, I wish we had that, I wish we had a bit of that in my organization. Or you're thinking, how do I get teams to behave differently? How do I engage my security team in this? So some of the practices that I would recommend that you look into, I think product management and user-centric design for your platform processes and systems goes a long, long way. Even a little bit of user interaction, like, oh, hey, dev team, how do you find that process? Is that good for you? Can give you insights in how you can help them do more and how you can take load off them. Taking a platform and DevX approach to security processes is something I've talked about, but that's what happens when you take a user-centric approach. You're going to be building processes and practices into your platform that allow you to be secure by default, that allow that can take some of that burden away from your dev teams. Build or buy. Select the right partners that reduce the noise in this process rather than create it. I can't emphasize enough. There are a lot of security tools that are just bad news dashboards. That's not cool. They should be helping you get better at this. And then finally, security need to change their mission. They're not the bad news guys. They're there as a partner. They should take on an educational and enablement mission within the organization, making sure that they're available to dev teams who do need their advice and want their advice if they're having to make decisions that impact the security of their clusters. That is everything I've got today, so I am going to abuse your time just slightly to tell you about 2 events that I'm running in London. I love going to conferences because I think the people that come to conferences are curious. They're curious, open-minded, willing to learn. Like, people I meet at events have become my friends, lifelong friends, and I just love it. I just want more of it. So I am organizing 2 events in London in the autumn. So in a couple of weeks' time, DevOps Days London, we have some amazing talks about platform engineering. It's going to be incredibly relevant to all of you in this room. But I'm also organizing a new event which is called AI for the Rest of Us, because I've got AI FOMO, and you might too. AI for the Rest of Us aims to take you from 0 to fluent in AI over 2 days of content. I have told all of my speakers that they must go slowly, use no jargon, and introduce every new concept that they want to talk about as part of their pitch. It's not necessarily a technical conference, it's not necessarily a non-technical conference, but we want to have better conversations about AI, which means we've got a hell of a lot of new terminology that we need to use. So that's my little plug for my events in London. Would love to see you there, and thank you.